Hi friends, welcome to Varun Techie channel, a place for better learning. Like, share and subscribe. Today we will discuss Machine Learning Session 13. Multiple linear regression. Multiple linear regression is a statistical technique used to analyze the relationship between two or more independent variables and a dependent variable. In the last session, we learned about simple linear regression where we have only one independent variable and one dependent variable. Steps involved in multiple linear regression. The first step is to define the problem. Clearly define the research question or problem you are trying to address. Identify the dependent variable and the independent variables that you believe influence the dependent variable. Next, you need to collect the data. Gather data for the dependent and independent variables. Ensure that the data is relevant, accurate, and representative of the population you are studying. The next step is explore data. Perform exploratory data analysis to understand the characteristics of the data. This may involve summarizing the main statistics, visualizing the data, and identifying any patterns or trends. The next step is check assumptions. Verify the assumptions of multiple linear regression, including linearity, independence of errors, constant variance of errors, and normality of errors. If these assumptions are violated, it might affect the reliability of the regression results. Feature scaling. This is an optional step. In this step, depending on the nature of your data and the regression algorithm you plan to use, you might need to scale or standardize your features to ensure that they are on a similar scale. This can help prevent one variable from dominating the others in the model. Split the data. Divide the data set into training and the testing sets. The training set is used to train the model, while the testing set is used to validate or evaluate its performance on unseen data. The next step is build the model. Use the training set to fit the multiple linear regression model. The model aims to find the coefficients for each independent variable that minimizes the difference between the predicted values and the actual values of the dependent variable. The next step is to evaluate the model. Assess the performance of the model using the testing set. Common metrics include MSE, mean squared error, R squared, and others. These metrics help you understand how well the model is predicting the dependent variable. Next step is to interpret the results. Interpret the coefficient of the independent variables to understand their impact on the dependent variable. The next step is make predictions. Once the model is trained and evaluated, you can make use of it to make predictions on new and unseen data. The next last step is validate and refine. If necessary, refine the model based on feedback, additional data, or changes in the problem statement. Validate the model's performance over time to ensure its ongoing accuracy and the relevance. Now we will see the code in Python for the multiple linear regression. First you need to import all the necessary libraries. The first one is import pandas as PD, and you need to import train test split, and you need to import linear regression, and you need to import the matrix to print the matrix. After that, you should load the data set, replace your underscore dataset.csv with your actual dataset file. After that, in the next two lines, we are assuming the target variable is the column you want to predict and other columns are the independent variables. In the next step, we are going to split the data set into training and testing sets. For training, we are using 80% data and 20% data we are using for testing. It is assigned randomly. After that, we are creating a linear regression model by writing model equal to linear regression of. After that, we should train the model on the training set. For that, we are writing model dot fit of x underscore train comma y underscore train. After that, we are going to make predictions on the test set. For that, we are writing y underscore pred equal to model dot predict of x underscore test, and we are going to print the mean absolute error, mean squared error, root mean squared error, and r squared. After that, we are printing coefficients and the intercept. This is the complete code for executing multiple linear regression on the given data set. The data set you are going to process, you can click on this symbol, and you can bring that file here by using this option browse, and you can bring that here, and you can write the name of the data set here, and you can process the data set. Thank